All right, let's move on with selection here. So selection is the process that takes one generation in the population to the next generation. And remember, this is the thing that models Darwinian survival of the fittest. So one thing that's important, though, to note is that before we do selection, we have to go through and redo the fitness of all the individuals in the population because we did the crossover mutation, which have changed those individuals and thus changed their fitness, okay? So we have to make sure that we go through and redo the fitnesses before we get into selection. Otherwise, selection won't work for us. So we're going to use what's called tournament selection. And tournament selection uses this algorithm where K is the tournament size, okay? And tournament size is just some integer greater than or equal to 2. I usually use 2. The higher the number that you use there, the more likely you're going to be pushing highly fit individuals into the next generation, which has a good side and a bad side. The good side is that you converge quickly. The bad side is you might converge quickly to a suboptimal solution. So 2 seems to work. Anyway, but here's how it goes. To make the next generation, for every individual in the next generation, we pick K individuals randomly from the current generation. Okay. Then we look at their fitnesses. Whoever's got the highest fitness moves into the next generation. Okay. And so an implication of this is that an individual might participate in an arbitrary number of tournaments, right? Every time it gets picked randomly, it's in a tournament. And so if it wins more than one, cool. That just means it has more copies of itself in the next generation. Okay, so every time you win a tournament, it makes a copy of your chromosome into the next generation. And so the more you win, the more copies of you survive into the next generation. And so what happens is over time, the highly fit individuals tend to dominate, and that's how you converge to a solution. So here's an example, and I hope I did these all right because I did these by hand. But our first tournament to pick spot 0 in the new population, the 2 people or 2 individuals selected for the tournament were 1 and 0. So we look at these 2 fitnesses, and these are the updated fitnesses, by the way. And we find that individual 0 has got the best fitness. So individual 0 from the old population becomes the new individual 0 in this population is copied over. Okay. Next slot filling tournament is numbers 8 and 7. Out of those 2, number 8 is the winner. So the old 8 becomes the new number 1 and it's copied into the new population. Then we look at 4 and 6. So 4 is I got a fitness of negative 151. 6 is negative 63. So 6 gets copied in. Then 1 and 2, negative 138, 193. The 1 gets copied, negative 138. Now here we go, number 4. To fill this slot, notice that we're actually performing the same tournament. We just selected same two individuals we just did, so we should have the same winner, number 1. And now he's got 2 copies in the next generation. 3 and 7, so 3 has got a fitness of negative 83, 7 negative 202.56, so 3 gets copied over. Then 6 and 8, 6 has got a negative 63, 8 negative 174, so 6 comes over. 4 and 6, negative 151 versus negative 63, so 6 gets copied again. 3 and 9, negative 83 or negative 106, so it should be the negative 83 gets copied over. And lastly, 6 and 0, negative 106 versus negative 63, and item number 6 gets copied over one more time. So again, notice how just by virtue of the tournament, and these were randomly chosen, by the way, I didn't do any rigging of that, but just by the random nature of this, 6, which had the best fitness in our original population, has got 4 copies of itself into the next generation. And so the highly fit individuals are the ones that move forward into the next generation. Okay, so that's how this works. Our next thing will be to take a look at a code tour. We'll talk about the files here and then their relationships, and then actually dig into the code next. So if you go to Git and do this command, or execute this command from your command line, you will pull down the genetic algorithm code that's the unit processor version. And so what it comes with is ackley.cpp and .h, which is a sample program, deong01.cpp and .h, which is another sample program, evaluate, which is the thing that goes through and evaluates everything in the population, sets its fitness, point crossover, point mutation, tournament selection. Those are all operators that we talked about. There's also a standard stats operator, which is used if you want to see the best, worst, and average fitness on a generation by generation basis. We won't be using that when we do our MPI runs. And then we have our abstract classes, operator.h, which is the root of all the operators, and problem.h, which is the root class of our sample programs, and of course a makefile. So as I said, problem is an abstract superclass to both Ackley and deong01, and we'll look at the specifics of this. And then our operator class is the root class for evaluate, point crossover, point mutation, standard stats, and tournament selection. All right, so those are our files. And in our next videos, we'll take a look at some of the code for that in particular.